Dear audience, here is Zhen Yang Luo. I'm from Seattle Central Community College. I'm taking Physics 100 this quarter, and my professor is Clark Willman. The project issued by Mr. Willman is called Measuring Reaction Time, and following is the presentation of my PowerPoint. First of all, we need to prepare the materials of this project. We need a reaction time measure sheet, which looks like this. And this sheet is gonna be hard, rectangle, and wide. Second, we need measured objects for this experiment. They're better mixed up: male, female, young, and old. Third, we use Microsoft Excel to draw the graph of those data we get. And finally, we use physics equations to calculate. Here's the process of this project. One person holds the measure sheet vertically and releases it vertically without any other forces on it. And the measured objects are supposed to catch the stripe as quick as possible. Meanwhile, the observer would use the stopwatch measuring the time from the sheet being released and being caught. Finally, record the data and analyze them. A reaction time sheet is supposed to look like this. And here's the graph I made. And here records all the data of measured objects. I have 20 measured objects, and I measured each of them 10 times and get the average as my answer. Here's the conclusion of all data. The average reaction time of 20 objects is around 160.245 milliseconds, and the standard deviation of all objects is 28.134. And now here are some questions for this experiment. The first one is, are there any patterns in the reaction time of subjects? Objects who are measured, they might decrease their reaction time by time. It's like after several times warming up, they reacted faster and faster. Additionally, I found out that people have shorter reaction time who are younger. For instance, one of my objects is around 17 and another object is over 27 who already has a baby. As a result, the youngest one, his average time is around 130 minutes, 30 milliseconds. The older one constructively has 190 milliseconds as his average reaction time. And also, generally, male react quicker than female. People who work out frequently is more nimble. Second, look up the acceleration of gravity for the Moon and for Jupiter. Explain how a reaction time stripe for each of these other bodies are different than the stripe you made for this lab. If we do this project in the planets which have greater gravity than the Earth, the reaction time sheet should use greater unit, like change the distance unit from cm or m to from millimeter to centimeter or meters, because the sheet will be falling faster. In addition, we should change the unit smaller if the gravity is smaller. The third question is, imagine that you were measuring the reaction time of somebody with an extremely slow reaction time. A. Would the current cardstock be suitable? Why or why not? My answer is no, because according to the physics equation, the length of this sheet will be longer than 20 millimeters, and the solution for this is we need to lengthen the stripe. And here's some personal discovery. The name of reaction time measurement is too general. We should specify it as the reaction time measurement of the right hands between thumb and forefinger. This is because people differ. Some of us are left-handed and others are not. If we measure the reaction time of right hand of a left-handed person, then he would consequently have a relatively slower reaction. The data used to form our experiment should be extremely general, which means the measured objects should be picked from different genders, ages, health conditions, and occupations. And third, because of the limitation on equipment and environment, the results of this experiment cannot be extremely accurate. Thank you for watching this.